Hi guys, welcome back to my YouTube channel. This is second part for RAG concept tutorial. Uh, in this video, I will be talking. I will be implementing the RAG pipeline in our Google Colab. So you have seen the RAG concept in the previous video, right? Um, this is all about RAG concept. So let's move on to the Google Colab and see the implementation part of RAG pipeline. So RAG pipeline, why we need first question, why we need the RAG? Because uh, LLMs are generally having the problems such as hallucinations, and it has outdated knowledge as the training has some cutoff, and it lacks the domain specific knowledge, explainability and trustworthiness, and fine tuning the LLMs is too costly as it requires a large infrastructure. So updating its knowledge can be done using this RAG concept easily, and that's why it is less cost and efficiency. So these are the problems RAG will solve uh, for LLMs. And we have also seen how the data is stored in the vector database. First, the knowledge base contains the PDF files or text files. These are converted using a embedding model from sentence transformers. These models are stored in Hugging Face hub. So we are using this version of this version from Hugging Face um, as an embedding model to convert text to numerical vectors, and then the numerical vectors are stored in ChromaDB vector database. Then later, when the user asks a query about the knowledge base or the book we have uploaded, uh, it will retrieve the similar vectors from that book using metric called cosine similarity, right? uh, then LLM gets the two inputs. One is the user asked query, and the other is filtered vectors. These two inputs will generate a more accurate response uh, based on the knowledge base. So here, uh, suppose a sentence is there: the cat sat on the mat. This sentence is compared with other three sentences here. So the first sentence has the higher numerical value of cosine similarity. So we can say that these two sentences are more similar in nature, and the other are less relevant. So RAG pipeline will consider or retrieve this first sentence and give this sentence as the input to LLM to generate the response, right? This is how RAG works. Now let's start the coding for this RAG pipeline. I will create a new cell. And install all the required libraries. So here we need LangChain community and community ChromaDB and LangChain text splitters. This is to split the text document into chunks, and PyPDF, and also LangChain Google Gen AI for LLM, and sentence transformers for embedding models, sentence transformers. Alright, these are all required. I have already installed all of these libraries, and we need to have a PDF file. So I am uploading it from my local drive, one ebook. I have uploaded it here. Then first, to create a RAG pipeline, first we need to import all the libraries. We need OS library, and to import to get API key from secrets tab from google.colab import user data, then from LangChain underscore community dot we need vector stores import chroma, then from LangChain underscore community dot embeddings import hugging face embeddings, then from LangChain underscore community dot for vector database embeddings, and still document loaders import py pdf loaders, and from LangChain text splitters import recursive character text splitters, and still from LangChain underscore core we need runnables import runnable pass through from LangChain underscore core dot still output parser to parse the output string, output parsers import str output parser, and LangChain underscore core dot runnables prompts import chat prompt template, and one more is LangChain Google Gen AI import chat Google generative AI. So I think these are sufficient. Once we try to import, here it says PyPDF loaders is not there. I think there is no S. and also splitters, not S. LangChain text splitters. LangChain text splitters import recursive character text splitter. As here's a spelling character. So cannot import. Okay. Right. The libraries are imported, required libraries. Now let's create a pipeline for this. RAG pipeline. Now define one init class init self and we need PDF path and also self dot also vector store equal to none, self dot, this is for QA chain, self dot text splitter equals to recursive character text splitter, and let's use chunk size as 1000, chunk overlap as 200, and self dot loader PyPDF loader and documents. This will not like this, but we will use documents chunks split documents. Here we will use if self dot let's use a different logic. We need PDF path for loading the path, ChromaDB vector database for vector store, QA chain text splitter, and one more for LLM. And in this I'm going to use model equal to model equal to Gemini 2.5 flash and API key equal to user data. Copy this name from secrets tab and use it here, and then last one, convert system message to human equals to true. Okay, this is for LLM, and prompt template equal to use the following pieces of context to answer the question at the end. If you don't know, answer this, not this format. Use the following piece of context to answer the question, and we will use context as in this way, and self dot prompt from chat prompt template will convert this prompt template into a prompt. All right, these are sufficient. Now let's define ingest pipe function that will inject data into our vector database. First, if we will try to load the PDF loader, and pages equals to, okay, this is enough, and embeddings also. Here we will create another one for embeddings, self.embeddings equals to Hugging Face embeddings from sentence transformers. If not if self dot vector store is none, we will initiate. Before this, we will process the document in batches, so we need one batch size variable, batch size total batches equals to, then if length of pages, this will calculate total number of batches. Then first we have to create a directory for our vector database, right? So here persist underscore directory is, will create in content underscore content slash db. If already exists, import os dot path dot exist, we will remove it. First clean path is needed, that's why we will remove it using shuttle library, shuttle dot remove tree persist directory, right? Now if self not here, after calculating batches, if self dot vector store is none from documents, pages, and did we use the text splitter? Yes. And embeddings equal to self dot embeddings persist directory, and this is batch, and let's close this. Else self dot vector store add documents as pages. This will complete the ingestion pipeline. Print ingestion complete. So let's just have an overview. First we will take the path and load the PDF file, split that into chunks, then create a directory. If that directory already exists, we don't want that directory, so that's why we are going to clean the old directory of vector database. Then we are creating we are processing our vector database, our text document in batches. So that's why we are having batch size and total number of batches. And here we have to iterate on these batches for I in range of 0 to length of pages, batch size, batch equals to pages of batch size, and include this logic in the for loop. This will iterate, this will process everything in batch. At the end, just print ingestion complete. Then we will define another class called ask that takes query as input. If self.vectorStore, if not self.vectorStore, then we will create persist underscore directory self.vectorStore persist underscore directory embedding function, and else print run the ingest method first. Right? Now if QA chain, we are trying to build the chain of a RAG chain. QA chain is none. This is, we are going to use LangChain Expression Language for RAG pipeline. If here this is self.QA chain, then self.QA underscore chain equals to context. This will include in double quotes context colon. We'll retrieve the data from vector database as retriever with top 3 searches. So the parameter we need is quarks k equals to 3, quarks equal to k value as 3 and another parameter, value is question runnable pass through. Right, this is the sequence we need. First we will retrieve, then attach it to prompt and pass these two inputs to LLM, then we will parse the output. This is the sequence we have to follow in building the QA chain, right? Then return double quotes, we will return as a dictionary result self dot qa chain dot, we will invoke using the query. After this, at last we will print setup complete using LCEL LangChain. Right, all the pipeline has been created. Just execute this once. If there are any errors, we will fix it. No errors. Setup complete using LCEL LangChain. Now we'll create an object for we will create for an object for RAG pipeline. RAG pipeline double quotes PDF underscore path equals to pass this PDF file path to that pipeline. So here it is taking PDF path as input, and it will initiate all these variables. Then using this rag underscore hf object, ingest, call the ingest method. Just call, execute this. It will take some time, so we will wait for it. It will process in batches. For every 1000 characters, it will process as a batch. Then before executing this, we will write the next code. Rag ask a question. For asking a question to this model, enter your question. Then enter your question rag underscore hf dot ask question. To display the result, we need display IPython import from IPython import. There is one error here, missing positional argument documents. So where it is? Okay. Self dot vector store is none. From documents, batch pages embeddings. Well, let's just clear this. Self dot vector store. Okay, it is not batch, it should be documents here. And for while processing each batch, we will display some print statement total batches, ingesting batch, and print batch size. Okay, now it should execute properly. Okay, it is taking some time. This document is about 23 MB. It has around 500 plus pages, so it should take some time definitely. From IPython markdown and display markdown format double quotes okay. Okay, it is starting the ingestion. First batch is 1000 characters. It is injecting into this directory. You can see it here. New directory has been created. Immediately after this, let's run this and ask a question to that RAG pipeline and see the result. Okay, second batch is also getting ingested. It is taking time. I will cut this and skip this part and show you the result. Okay, cannot import markdown. Let's use auto suggestion feature from ipython.display. Okay, this should work. It is asking the question. We can ask a question about the book. What is the purpose of this book? So see, run the ingest method first. Okay, it has generated some text. The purpose of this book is to provide a visual and bibliographical analysis of major artistic approaches and blah. So it is working. There might be some logical error to get this run the ingest method first. This one is getting called, right? So it might be some small logical error. You can ignore that one, and this is how you can build a RAG pipeline. That's it for this video, guys, and I hope you like this video. Please like, share, subscribe to my channel, and I will see you in the next one. Thank you.